Y'all, this is the first episode of my LeetCode Path to Pro series. Today we'll be solving two-sum, the first LeetCode problem. So this series is, for me mostly, it's to kind of document my progress as I get better at LeetCode problems, and it's a fun way to kind of see that, and then as well I think it's good practice for interviews. Yeah, sorry, I just recorded this actually, but I deleted it. So I'm gonna try to record it again real quick. So I'm pretty tired and maybe a little cranky because of that. So yeah, today we're gonna be solving two-sum. Two-sum is, I don't know, it's because it's the first problem. I guess it's an infamous problem. But it is, you're given an array of integers, nums, and an integer target. You're returning the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you can't use the same element twice. You can return the answer in any order. So if we look at these examples, for this first example, we're given this array, nums. It's got 2, 7, 11, 15. The target integer is 9. 2 plus 7 obviously equal 9. So we're returning the indices 0 and 1, which go to 2 and 7. Pretty straightforward there. And then here, example 3, nums of 3 and 3. This is where it's a little, because this is a very similar example to that. 2 and 4 equals 6. So we're returning indice 1 and indice 2. Example 3, we have nums of 3, 3, target 6, output 0 and 1. So you have to be a little bit careful here. Because if you're not, then your algorithm might just return 0 and 0, because yeah, depending on your algorithm, whatever. So this is definitely not the most optimal solution, but this is kind of the most intuitive solution for me that I thought up. So I've solved this question. I think I watched a LeetCode video on how to solve it first, and then I tried solving it again on my own, and this is the solution I came up with. It's definitely not the most optimal. I wonder, actually, I'm curious, how long sort, what's the type complexity on this? Because I do use sort. O(n) log n. So you already have O(n) log n, plus. No, maybe not plus, but maybe multiplied by, the actual algorithm part, which I think is O(n). So yeah, let's get into it. So first, what I thought is I would like a sorted array. That would make this a lot easier, because then I could implement a left and right pointer solution, right, if it's sorted. Because then I could just check, okay, does L plus R equal our target? If not, if it's too big, if it's sorted, we can just decrement R. Decrement R, kind of looks weird on this. Decrement R, but then if our L plus R is too small, we can increment L to make our left plus right bigger. So that was kind of what I thought. So let's go ahead and try to code that up. So we're going to have nums2, which is going to be our copy of nums1 of the original nums array. And then we're going to sort nums2. We have a left pointer and a right pointer. And right is going to be length of nums2 minus 1. We're setting it to the end. And that's how you do that. Set it to the end of nums2. Oh man, can't believe I deleted that video. So bummer. So here we're going to do while left is less than right, because this means that this while loop will run for as long as left. Sorry, it's like flipped on this little screen. Left, well, left doesn't get bigger than right. And if if that happens and they get closer together or whatever, and left crosses over right, we would have already calculated that value. So this while loop should work. Left equals right if. So the first scenario is obviously if they equal each other. So if nums2 of L, or I mean if nums2 of L plus, yeah, I'm tired. Nums2 of L plus nums2 of R equals target. So that's our target integer, right? We are going to want to return. But we can't just return nums2. We can't just return L and R, right? Because in nums2 it's sorted. In nums1, the original, it's not sorted. So we need to figure out the indices in nums1. So we're going to have index of L. We're going to set that equal to nums.index. Sorry about that. Thought I got a text from Peggy, but yeah, it's my landlord. So what do we got? So we're setting index of L. That's going to be the point that nums2, right? Value. So this little number right here, this is basically this index function. So this index function is going to be working on nums. So it's going to be looking in nums for this first index that this value of index of L in nums2 can be found in nums, right? So that way index L and index R here equal those indexes in nums instead of nums2. Yeah, I like this. I like why I'm talking about like the video thing. Because that's maybe the best understanding I've had of this. But actually, we can't just do that. We actually have to do something else. So we actually have to set nums of index L, the value. We have to set that equal to none. And that's because of cases like example 3 here, where we have the same value repeated, and they're both used for the target, right? Because if we didn't, it would say, okay, L and R here, 3 and 3, A equals target, great. We found it. Oh, because the searching thing. So it's going to find the first index in nums that equals 3. In that case, it's 0, right? So that's why after we find this 3 as 0, here we're going to set that 3 to 0, as in the value, not the index. So that way, when R comes looking, index R comes looking, okay, where's the second 3? This is going to be 0 now, so it goes to this one. So we get an index 1. Great. So we're going to return index L and index R. It doesn't matter the order. Okay, so that's the first case. If it works, which is great. It'd be awesome if it worked every time. else if, just copy and pasting a little faster, nums2 L plus, what if nums2 of L plus nums2 of R is greater than target? Right? What are we going to do there? That means we need to decrement our R. And then the final case would be if nums2 of L plus nums2 of R is less than target. And in that case, we need to increment our L. And that should work. Haha, nice. Okay, let's see if that works. Alright, cool. So let's see. Yeah, the time complexity of this, we're going to have O(n) log n for the sort. Copy probably also has some extra time complexity there. And then this is just O of n. Because at worst, you know, we're sorting through, we're looking at each index in the array. But it's that plus O(n) log n, or O(n) log n plus whatever copy is. Python complex. O(n). So yeah, this is a pretty slow. I think I could definitely be calculating that wrong. You know, I'm still working. I think I just finished reading that section and cracking the coding interview. But you know, still a work in progress. So yeah, the memory is not that bad though, which is nice. So yeah, cool. See y'all.